A lot of excellent, unqualified opinions, live streams coming up with some pretty fantastic guests, including today's guest, founder and CEO of Helium, Amir Haleem. We're going to talk about the future of telecom. We're going to talk about their new tokenized network that's helping to bring wireless networks, low impact wireless networks to cities across the world, starting with Austin. So we're going to talk a little bit about that. Industry in some respects could put a bit of a stranglehold on crypto if they were to ever censor transactions. Timely conversation as Amir and his team just completed a fundraise a few weeks ago from the likes of Union Square and Multicoin. Disclosure, Multicoin is an investor in Messari. But super excited to welcome Amir. Amir, I know that intro did not do justice to what you're working on, but why don't we just start off with the basics? How you kind of came to this project, what your crypto origin story was, and how it's kind of intersected to bring Helium to market, and how you guys have gotten off to such a fast start.
Cool, thanks. Yeah, it was actually pretty good intro. So Helium's been around for a little while, and we have always been trying to solve the same problem, which is how do we build ubiquitous low-power wireless networks? And we've sort of had this opinion for 6 or 7 years. I co-founded the company with Sean Fanning from Napster, and our belief at the time, and still very much true, is that low-power things like sensors and tracking devices and stuff that look like this, tiny little things, just don't have a wireless network to use. It's sort of that simple of a premise, right? It should be low power, it should be ubiquitous, it should be incredibly cheap, and none of those that combination of things just doesn't exist today. And so that's always been the problem that we tried to solve. And crypto for us is a more recent addition. So probably 2.5 years ago, we started thinking about, what if we could sort of flip this whole business model on its head? Because one of the challenges of building low power wireless networks is that the applications generally don't want to pay very much to use them. Mm-hmm. And so building out expensive infrastructure in the way that cellular networks have been built today, and trying to recoup your costs by charging people to use them is much harder in the low power space, because people are sending like temperature readings and location data, stuff that is on the order of bytes rather than gigabytes. And so we sort of thought about it and said, what if we just flip this on its head and sort of just abandon the whole idea of trying to make money on the network itself, and try to sort of create this incentive structure and this model that encouraged people to act as their own network operators. And so we've been sort of nicknaming this thing the People's Network. And that's sort of the approach that we've taken. Like we've built a blockchain from scratch and come up with a sort of novel consensus protocol that really tries to incentivize people to act as network operators by running these devices that we call hotspots. And so that's that's like a 6-year story attempted to be summarized in 2 or 3 minutes. I'm sure he did a mediocre job.
And could you just elaborate a little bit on kind of mesh networks in general and the impact that they could have on something like the Bitcoin network? Right, so obviously, if you're talking about 3G, 4G, 5G data and video streaming, it's much higher bandwidth, and that's something that takes quite a bit of fiber and quite an expensive infrastructure to actually facilitate. That's probably going to stay in the purview of the telecoms for the foreseeable future, or maybe that'll change someday. But right now, you are talking about you're talking about Internet of Things devices, so low bandwidth devices that I would imagine include things like Bitcoin nodes, Ethereum nodes, and other crypto networks.
It depends, right? I mean, I think the bandwidth requirements for a typical Ethereum node, for example, are pretty high, right? There's a lot of traffic there, a lot of syncing. The blockchain is big. And so that's not the kind of application that we would think of running on a network like this. Like this is a network that has data rates that are 1 to 20 kilobit per second, right? So mm-hmm. Very, very small. And so I don't think you would look to run a full node that way, although potentially light clients and other stuff like that could exist this way. And I know guys like Gotena are working on these sort of mesh networks that interoperate with Lightning and Bitcoin in general. But our structure is less of a mesh and more like a traditional model, more like a cell model, where you have a base station and devices connect directly to that base station, and they don't hop through each other, right? So mesh networks are where you have like a bunch of different end nodes and they communicate through those nodes effectively to get back to the internet somehow. And we don't do that. Everything in our case is a single hop. So you have a hotspot device, and it can listen to tens of thousands of end devices as long as they're in range of that hotspot. And so there's no meshing in our system per se.
And can you talk a little bit about the Austin pilot and the economics to get a city up like that, up and running, and then maybe some of the use cases for folks who might be considering purchasing one of these devices? Is this just something that a user would do as an experiment? Because I remember the 21 computer was the one line pitch that people kind of laugh at now was mine Bitcoin from your toaster. And obviously
right.
the economics of that were terrible, right? This is a little bit different because there is some type of consumptive use, but there also could be some type of payback period. One, the device isn't that expensive, so you wouldn't necessarily call it a major investment, but it's enough where it'll give people pause. Is this going to be primarily for hobbyists early on, do you think, or is there kind of real models that can emerge around this?
Yeah, so there's sort of two sides to the universe, right? I mean, there's the supply side, right, which is people building the network coverage, right? So in Austin, we typically we have this wireless protocol that we call long-fi. It's extremely long range, and so a single hotspot could create anywhere from a mile to 25, 30 miles of network coverage. And so the economics of building citywide coverage change a lot when you have that kind of capability, right? Where a single hotspot that's placed well with like a decent antenna could cover, large parts of the city. You start to sort of realize that you could build this out in a reasonable way, only needing 150 or 200 people per city. And so that's what we've been targeting. So I think we have around 200 in Austin. I don't remember the exact number. So we sort of hit the cap that we wanted to hit there. And so the economics are sort of interesting in this case, right? I think most crypto assets today are very speculative in nature, right? There's not that much utility underlying a lot of these. There's some, but not all of them. In our case, like we use crypto as a way to basically build a wireless network. If you saw in our press, we're working with companies like Lime, and Nestle and Agulous and Invisileash and companies like that are building end products. So in the case of someone like Lime, it is the desire to be able to track scooters when they're stolen, which I'm sure you guys have all read happens often. In the case of someone like Nestle, it's all about like optimizing supply chains. So it's like they've got this water delivery business where they drop water off to like water coolers at businesses and offices, and they have no idea how much water is being consumed there. So those are just like simple applications that you feel like should be easily accomplished today, but just aren't because it's either the service plans are too expensive, or the hardware is too expensive, or it's all too complicated, or there isn't network coverage, or it's always some combination of things that makes this hard. But this is truly a utilitarian network.
Austin, it sounds like you've got some of the infrastructure in place, but as you think about the testnet, mainnet kind of schedule, what are some of the key milestones over the course of the next year?
Yeah, so Austin is sort of the mainnet launch for us, and that's August 1st. So that's a scary time because our blockchain, I think, is quite unique in the sense that each of these hotspots is an actual miner on the network, and there's no sort of big cluster of nodes that acts as sort of the main consensus origin there. So each of these hotspots is sort of running the blockchain itself, and so our consensus protocol is kind of interesting there. So it's going to be an interesting time, like deploying something like this in the wild. But that's August 1st is when we're doing it. We intend to ship to the rest of the country by October. We may accelerate some cities ahead of schedule, but we'll see about that. We want to start getting into Europe next year. I mean, Europe, I think, is a huge market for both crypto and IoT in general. So I think there's a massive opportunity there. And in terms of long-term roadmap, I mean, something you said there, I think it's sort of interesting to think about, which is that we view this as a mechanism to like deploy wireless infrastructure in general. Like we happen to view low power networks as the least well served today. Like there isn't really good infrastructure for those kinds of things. But you can imagine how something like this could work in the realm of something like 5G, especially when you think about how many base stations are required to deploy 5G networks. And there's a lot more complexity there. There's like backhaul questions, and there's a lot more complexity with how you do that. But ultimately, if this succeeds, like we would view it as a roadmap to like deploy other wireless networks this way that are sort of beyond just low power applications.
And as you think about scaling, so you said it's a couple hundred of these devices to cover a city. How many IoT or other low bandwidth connected devices can those support? Do you have to scale the network as the number of devices increases that leverage that 200, or does that stay pretty static, based more on kind of redundancies and just geographic coverage?
Yeah, I mean, I think eventually you would probably you would probably need a little bit more capacity than that as the network gets really on full tilt. I mean, if I remember, and I'll probably butcher these numbers, but I think each hotspot can support around 300,000 devices connecting per hour. So if you multiply that out by 200, you're supporting like whatever 60 million devices per hour, and that's probably pretty good for the time being. But we'll see. It depends on the kinds of applications. Like if you have an application that is constantly sending data all the time, or like pinging locations every second or something like that, then you could sort of quickly need more capacity than 200 hotspots can supply. But for the most part, like, we feel pretty good about 150, 200 being a number that gets you pretty strong coverage. And of course, like, augmenting it is not that complicated, right? I mean, the hotspots today we're selling for $495. But you will also be able to DIY your own hotspot for less than that, right? And so adding more hotspot capacity is relatively inexpensive when you think about the cost of like deploying cell towers, for example, to try and do the same thing, which is $100,000 plus per site.
Mm-hmm. Could you give a sense for the potential cost savings? Just rereading the Multicoin guys' post, they mentioned things. You mentioned Lime, so maybe we'll go with that. But they mentioned pet tracking, and you mentioned the scooters. How much cheaper is this, and how much more or less reliable would it be to use a network like Helium versus 3G or the telecoms? Because it seems like there might be a trade-off in performance, but I'd love to know how you think through actually scaling that up and getting to the performance that you need to work with someone like a Lime or with a large national pet chip tracking company.
Yeah, so starting with the cost, I mean, in some settings, this is something like 1,000 times cheaper than the way you would do it with cellular. And this is constantly in flux, right? I mean, the guys like Twilio and the cell companies are constantly sort of beating that price down. And so one way of thinking about it is just, what does it cost versus cellular? The other way of thinking about it, which sort of gets to your other question too, is that this is unlike any cellular technology that's available today. So there's a new thing called NB-IoT, for example, that the carriers are rolling out, which is a low cost, a low power and low cost version of cellular. But even then, it is anywhere from 10 to 100 times less battery efficient than what we're doing with Long-Fi. So it becomes difficult to compare the two in a way, because there isn't really a sort of direct equivalent. Like, there is no low cost version or low power version of cellular that sort of matches what we're talking about. But that's what we think. I mean, if you looked at it compared to some of the pricing out there that we've seen today, which is $20 to $30 a month or something, it's thousands of times cheaper than that to use our network. In terms of like the reliability and redundancy, I mean, one of the interesting characteristics of this network, compared to cellular, is that we don't really have this like notion of being attached to a hotspot. So if you have a scooter, for example, that's just zipping around Austin, and it transmits a GPS location or some other reading, like a battery reading or whatever, any multiple hotspots will probably hear that at the same time, because the sensor isn't associated with a particular hotspot. So it just transmits. We've noticed this in San Francisco in our testing, like several hotspots receive it at the same time, because the range is so large. And so you end up with pretty good redundancy this way. I mean, we have, I think now, about 30 hotspots in San Francisco, and it is very rare that we go anywhere in the city with a transmitter and are only heard by a single hotspot. And so you get good redundancy even with 20 or 30 in a city like San Francisco, which is complicated by hills and stuff like that. So we expect that the redundancy created that way in Austin will be pretty good. We have one of our investors is Munich Re, which is one of the world's largest reinsurance companies, and we've had conversations with them around can you offer SLAs effectively via an insurance policy on the network, and so there's interesting conversations that are happening there that I think could be really, really interesting. But fundamentally, like, just given the way the protocol works, given the range, we don't think that we're going to run into too much of a reliability concern, just because there'll be so much redundancy with that many hotspots in the city.
Mm-hmm. We got a question in from Tom Shaughnessy at Delphi. He asks, is there any way that the ISPs can block the reselling of their data? Because it seems like at some point you're going to be on a collision course with some of the local telecom and ISP providers.
Yeah, I mean, there's sort of, I don't know, there's two or three answers to this. I mean, one is, like, we think you should be able to do whatever you want with your own internet connection. So that's fundamentally, that's our first position, is that, screw those guys. But from a more, like, practical point of view, the kinds of data that get sent and received here are so small. Like, just as an example, like a GPS packet is in our network is something like 35 bytes, right? So it's absolutely tiny, right? And so at some volume, maybe that becomes significant, but I think identifying that kind of traffic, identifying that it's a hotspot and then blocking it is just a lot of work for ISPs, and I don't know that they'll ever bother with it. And if they do, we can always look at alternate tactics like using Tor and other things to obscure this. But I stand by the first part. I find it obnoxious that you can't just do whatever you want with your own connection, and that's what we're going with.
Well, certainly makes some sense. There's been a couple of other companies, projects early on that were focused on, kind of creating these networks for IoT devices. Filament comes to mind, which is a project based out of Colorado. Why do you view the time as right now, and what are some of the things that you've learned or borrowed from some of the other major blockchain protocols that are kind of the most integral design components of your own network? Because you are spinning up something from scratch. There's a pretty unique consensus mechanism that you're implementing. It makes intuitive sense, but I'd be curious if you can kind of draw on some other parallels, or what some other projects have already built to help people better understand this network and how it operates.
Yeah, that's a hard one. So we certainly gained a lot of inspiration from looking at other projects. So that the simplest way of thinking about it is the network is a asynchronous BFT protocol. At the end of the day, we use this thing called Honey Badger BFT, which was designed by this guy Andrew Miller. He's a professor. I can't remember exactly where, but he's been involved in the crypto space for a very long time. I think he's involved in Zcash. And we liked Honey Badger because it's asynchronous, so messages can sort of arrive at any particular time. There's no timing guarantees required, which we thought was important in a network like this, because people are going to be connecting hotspots over all sorts of different internet connections, right? They're not going to be in data centers. They're going to be on people's home networks and wherever they may be. And the way what's interesting about our system is that usually, I think in these sort of BFT type setups, like if I thought of something like Hashgraph or EOS or anything that looked like that, or Stellar even to some degree, like they pick their consensus members, and that's sort of it, right? So EOS had this block producer thing, and there's 21 of them, and those are the elite few, and Hashgraph has the council or whatever it is, and we never really liked that model because it's sort of very centralized in nature at some level. Like someone picked that group, and it's unclear how you would ever replace them and without completely forking the network. And so what we wanted to do was have this PFT consensus group, but cycle the members constantly. And the way we do that is we have a Sybil resistance system that we call proof of coverage. And it's, difficult to describe well, at least I don't think I'm very good at it, but it's a challenge response protocol that happens over the wireless network. And so basically hotspots that are sort of close together, within miles of each other, send and receive these encrypted onion packets to each other that are layered and can only be decrypted by the specific hotspot that was supposed to receive it. And we use this system, and it's more complicated than I can probably get into in a reasonable period of time, and I'm very bad at describing it. But what ends up happening through that challenge response system is that hotspots gain and lose score. So over time, hotspots are losing score. The default state is that you are losing score and that you're dishonest. And you increase your score by actively participating in the proof of coverage protocol and submitting proofs to the blockchain. And as you do that, your score increases. And every 30 or so blocks, we elect the best scoring hotspots on the network to become part of the consensus group. And so constantly cycling out the consensus group, we think is a very unique characteristic of the network, and also very scary because no one is really in control of it at any time, right? It's just constantly electing the next best 100 hotspots to be. The fact that the mining power can't really be consolidated in any way, like there's no benefit to like buying 100 hotspots and putting them in your office. You won't increase your score that way. Like they have to be distributed out into the wild. And so the sort of miners in our network are very broadly distributed. The consensus group that runs the network is constantly changing and electing among the sort of highest scoring nodes. And so we got some of these tricks from, I forget the exact network that we drew inspiration from for this, but it was the first time that we had seen sort of one system be used to sort of bootstrap another. And so we used proof of coverage to bootstrap, our Honey Badger BFT. A paper that we read around preventing DDoS attacks by requiring a similar kind of mechanism to gain access to a server. And it wasn't applicable to what we're doing because RF only has a limited range. It can't, you can't. No one can sort of target anyone else. Like they have to be at least within miles of each other. And so we drew some inspiration from that and sort of modified it along the way. But yeah, there's a lot of really interesting projects out there that we looked at to sort of think about this. But in terms of building a wireless network, like we're not really aware of many others that have tried to do this. Nodal is one that comes to mind, but they're using Bluetooth, and we just don't think the range of Bluetooth is feasible for building citywide networks, as we've seen with things like Tile in the past. I sort of kept a little bit of an eye on what Filament's doing, but I don't think they're in the sort of wireless network building business. So I think they're probably on a slightly different tangent.
Are these city-specific networks? So it's because you're starting in Austin, right? What happens when you move into New York? So you'll have New York and Austin. Will those be two separate networks with two separate consensus? Or two separate blockchains? How do you think about consensus in a multi-city system so that you don't have a situation where in New York you're going to have maybe as large a population of devices, of users that are participating in the network, and maybe that's larger than the next 5 cities combined. So does New York then become the largest stakeholder in the ecosystem that's actually providing proof of coverage? And if you extend that out, does that create any geopolitical challenges as you scale to other larger cities internationally?
We don't think so. I mean, so we spent a lot of time on like how the scoring system works, and I think it differs pretty substantially to what's in the white paper at this point because we wrote that so long ago. But we've tried to so the proof of coverage challenges are rate limited, so they can only be submitted and requested at a reasonable interval. And the scoring system, as I said, sort of penalizes people being clustered together too much. The real issue is that you're going to have hotspots that are sort of lone wolves that are just sort of sitting out there on their own. They'll get some mining rewards for participating in the proof of coverage as sort of as a challenger, as we call it in our system. But Those guys, I think, will on average, earn a lot less than people that are in densely populated cities like New York. But we don't think, for example, that New York would dominate Denver or something just because there happen to be more people there.
Yeah.
And the network is a single sort of large network. So we've talked about sort of future scaling, where you may have separate consensus groups that sort of bubble up to a singular main consensus group. But today it's a single group. And sort of one of the interesting characteristics of the wireless network that we are able to create this way is that we've sort of created this gigantic VPN, right? So any device that uses the network can talk to any hotspot, but have its data routed in an encrypted way to the correct endpoint, right? So if I'm Lime, and I have a bunch of these little tracking devices in my scooters, this works. And that's actually one of the major issues that we've seen in low power network deployments so far today, is that they're very fragmented, right? There's a bunch of different companies that have a bunch of different low power networks, and they don't talk to each other. And there's nothing that resembles a roaming standard or a roaming specification that really works. And so if you have, like a LoRaWAN device today or something, there's no way of you really sort of taking that between networks. And often these networks overlap in the same city. And so, the whole roaming problem is really a big one for an end user, because they don't really want to have to think about that, right? They just want the device to just work. And one of the benefits that we get from having this sort of distributed ledger that everything can inspect is that we can route data to the right endpoint, as a result of looking up device IDs and things like that. So it's we think a relatively clever system that leverages a lot of what we've learned over the years, which is things like enterprises don't want their data to go to a startup servers and stuff that in hindsight is relatively obvious, but is difficult to implement from a technical point of view, or at least implement well.
Last question I have is just on kind of size and scale of the opportunity, because and I'll make the disclaimer for you, this is not investment advice, this is for information only. I'm just trying to do kind of back of the napkin market sizing, right? So obviously one of the theses in building out this type of network has to be that there's going to be an explosion of IoT devices. Something like Helium could potentially unlock the usefulness of many other low bandwidth devices. So there's kind of a pretty clear kind of macro IoT play here. But if you just kind of look at the current snapshot of the world, what type of value could be captured by users in a network like Helium's if you replaced or were able to take just like Lime internationally to begin using this as the communications protocol versus going through their local wireless carrier?
And I think the aggregate opportunity size is extraordinarily large. I mean, depending on who you talk to about this and which analyst you like, you'll hear numbers thrown around that are devices in the tens of billions range over the next several years. And it's always a little bit difficult to take those things seriously, because I think they've been making the same claim for about a decade now. So it's always difficult.
That's the number of devices, right? I'm talking about what type of economic value at the communication layer where you are would potentially sit there.
Yeah, it's difficult to say. I mean, it's difficult to say because there isn't a perfect parallel today that you can draw. There isn't a good example of a network like this that you can look at. And so I think number of devices is the only reasonable way to sort of start thinking about what the opportunity size could be. And then sort of backing that out into how much could a single hotspot capture in a single city, for example, gets, significantly more complicated. But in terms of, just the way I think about this, or a way to think about it, is that we expect the number of total IoT type or low power IoT devices to be in the tens of billions over the next several years. We know that cellular carriers are spending tens of billions or more dollars building out narrowband IoT networks that aim to solve the same kind of problem. And so if you put at least those two things together, you get some sense of the scale of the opportunity here, which is that if a network like this succeeds and gains any kind of market share, and if you end up in 400,000 or 500,000 Lime scooters as an example, and we have another customer that will announce soon that is in a similar size, like 300,000 or 400,000 units over the next 2 or 3 years, you start to imagine that the potential sort of owning a piece of that network or being your sort of own network operator is potentially very lucrative. And so that's the best way that we know how to estimate the size of this now. And we have various sort of token economic models and things like that. But yeah, I'm sure you'll understand with the regulatory climate, we're not really going to share them with anyone. But we think that the opportunity is substantial to participate. And that's sort of the rationale for really doing any of this. I mean, that's why the company exists. That's why we thought that this was a good opportunity in the first place. And we've sort of been encouraged over the years that no one has actually figured it out very well, right? Because of the economics that I mentioned at the start. Building the network yourself, the way that Sigfox has done it over the years, for example, is just extremely expensive. Mm-hmm. And so there's a very difficult path to monetizing the network back when you are hundreds of millions or billions of dollars into it. So we think distributing the economics like this is the right way to go from sort of a privacy and security perspective. We think this is the only way to do it. That makes any sense, and we hope that over time, we will start to be able to extend this strategy into other spaces that, are in dire need. I'm continue to be frustrated by only having Comcast as my broadband option at home. I would love to have alternatives, and so I hope that 5G and other technologies like it sort of bring about that change, and that things like Helium can participate in that and sort of distribute that a little bit more evenly.
Well, it's certainly an exciting vision. We're going to be on the lookout for how things go beginning of August. So best of luck in the meantime. Where can people find out more information, get their devices, or start playing around with the code?
Yes, so Helium.com is our page. The store has been online for a few weeks now. So if you go to helium.com/store, you can buy devices now. And so, of course, if you're early in the mining process, you're sort of disproportionately earning tokens versus being later on in the process. So if you're interested in participating, now is definitely the right time. In terms of code, we have a GitHub repo up, or an organization, github.com/helium. Some of the code is open source there, so I think the peer-to-peer libraries and some distributed key generation stuff and some of the crypto primitives that are there. We'll be open sourcing pretty much all of the rest of it very, very, very soon, which includes instructions and guidelines on how to build your own hotspots and participate that way too.
Excellent. Well, Amir, thank you so much for joining us. This is good to be back after a brief hiatus. So I guess thank you for helping me knock the rust off, since I've been tied out the last couple of months, which we'll have a couple of announcements soon, and hopefully the radio silence will make sense. But we'll be on the lookout, and we'll throw this up both online. It's already available live. We're also going to convert this into a podcast with the Blockworks group, who we'll be relaunching with in the next couple of weeks here. So we've got a slew of shows that are going to be coming live as we relaunch with Blockworks Group. Stay tuned for more unqualified opinions, especially in the back half of July and into August. We're just getting going. Until next time, thanks guys. Peace.